Hi class, I just wanted to record this short video regarding oxidation and reduction, just to kind of go over it a little bit. You guys should run into this in your reading. I want to make sure that you guys understand this. So basically, in order really to understand chemical energy, we need to discuss electronegativity. And electronegativity is going to be the tendency of an atom to attract the electrons of other atoms towards itself during bonding. We have an example here of CO2 where we have two oxygen atoms and one carbon atom, where the red is going to have high electron density, is going to want to attract electrons towards itself, meaning it has a high electronegativity, where the black or the carbon atom is going to have low electron density, is not going to be very attractive towards other electrons, and so it'll have low electronegativity. Okay, so this means that fluorine and oxygen have high tendency to attract electrons towards themselves during bonding. The way that we kind of know how electronegative something is by looking at the elements of the periodic table. Here, if you look towards the right and towards the top of the table, these are going to be the elements that will be the most electronegative, and they'll kind of decrease as you go down and out. So kind of an easy way to just know at a glance if you look at the table. So when we're talking about electronegativity, we need to also talk about oxidation. I can't say that word, so I apologize, guys. Carbon with a positive oxidation state is called oxidized, which is consistent with the oxygen that makes up the CO2 molecule. So when you see an atom bonded with O2, the other atom is typically going to be oxidized. Okay, so, we're looking at CO2, then that means that the carbon is going to be oxidized. Okay, the oxygen is going to actually be more electromagnetic, or it's going to attract more electrons towards it. Now, I understand completely that this is super confusing, so I didn't come up with the terms. I would not have done this if it was me. But if something is considered reduced, that means it actually is gaining electrons. Kind of not what you might think. You might think of it opposite. So try to do whatever you can to remember this. But I did steal this from Dr. Walsh. This nice little acronym she came up with where Leo the lion goes grr. So, if you think that if it's losing electrons, then it's oxidized. And if it's gaining electrons, then it's reduced. Okay, so hopefully that helps you remember. I don't know what else to say on that one. It's one of those things, right? So is the carbon and carbon dioxide oxidized or reduced? Now, I kind of already let this one slip in an earlier slide, but remember we went up here and we were talking about how any atom bonded with the O2, the other atom is typically oxidized. So in carbon and carbon dioxide, that means that carbon is actually going to be reduced. I'm sorry, the oxygen is going to be reduced, but the carbon is going to be oxidized. So see, now I'm getting it confused. I apologize. So oxygen is reduced in CO2, meaning it's going to be more electromagnetic or attract more electrons towards it. And carbon is going to be oxidized, meaning that it's going to be giving up atoms and it's going to be less electromagnetic. I am really struggling today talking. Okay, so is the carbon in methane oxidized or reduced? It might help you to look at the periodic table on this one. Okay, so methane is going to be CH4, right? So carbon will be right here, and then we also have hydrogen is being right here. Well, since carbon is more towards the right, then the carbon is going to be reduced and the hydrogen will be oxidized. Remember, Leo goes grr, okay? Now, so it hogs electrons. Sorry, apologize there, guys. So, this circles us back then to this photosynthesis. Okay, this is basically what the photosynthesis is going to look like. Okay, we have CO2 plus water that combines with sunlight to produce carbohydrates and oxygen. Okay, so is carbon oxidized or reduced during this process? Please watch the next video to figure that out.